Every meteorite has basically a special story to tell.
The treasure of the ages, stones from across the night, an eye unblinking since time began, that watched the blue planet when life began.
Some of the questions that we tackle are actually mind-blowing, I would say. What's the origin of water on Earth? How do planets actually form? Understanding the origin of life is sort of a question which touches your soul. So my name is Martin Bizzarro. I'm a professor at the University of Copenhagen. I'm also the director of the Center for Star and Planet Formation, and I'm the curator of the meteorite collection at the Natural History Museum of Denmark. When I see a meteorite, I just don't see a rock. There's information which is hiding in that rock, and I need to extract it to bring this meteorite alive. So for example, a meteorite from Mars is not just another rock from Mars because it may be a certain age, which tells us something about the surface of the planet at that time. A meteorite, for example, that comes from the outermost solar system, that's the region where comets form, tells us about this very unique and primitive part of the solar system which has been unmodified for 4.5 billion years. I see it as an opportunity to enhance our knowledge about the solar system when I look at each of these individual meteorites. Try to get them to tell me their stories. A meteorite, so that's a good question. A meteorite is actually a fragment of either an asteroid or a planet that lands on Earth. So imagine that you have Mars as a planet, and Mars can be hit, for example, by an asteroid or a meteor, and when that happens, it knocks off a piece of the surface of Mars, and eventually that piece can land on Earth. So we call that a meteorite from Mars in that particular example. So we have a collection here of approximately 1,000 meteorites. It's important because the first thing, it allows us to do research on this very rare and unique material and answer scientific questions which are really at the forefront. So what's the origin of water on Earth? How do planets actually form? How do they accrete? How do they differentiate? How fast does that happen? Which is understanding our origins. Where do we come from? You need a reference sort of composition because you always relate the composition of the Earth with the original composition of the solar system. And meteorites actually define this original composition because the primitive meteorites have been unchanged since they formed, since 4.5 billion years ago. And so these meteorites contain all the raw ingredients that were present when the planets were actually forming. So imagine that when the Earth was young, if these types of meteorites bombarded the surface of the Earth, they could have seeded the Earth with this prebiotic chemistry. This is a piece of the moon. It's another box I need to find, but it's like 50 kilos, this piece. Three most interesting meteorites which I work with. The first one would be the Black Beauty meteorite from Mars, which comes from the southern hemisphere of Mars. That's the oldest part of the planet, and it basically contains minerals which date back to the very, very beginning of the planet, all the way down to 100 million years ago. So from 4.5 billion years to 100 million years. In that rock, you basically have the entire geological history of the planet in your hand when you hold this rock. You become a child again because you find the first meteorite and you're super excited, and then you want to find more and more and more, and it's just like a treasure hunting. When a meteorite falls to Earth, it gets modified in the atmosphere. It experiences heating from the resistance with the atmosphere, and the outside of the meteorite, let's say 1 millimeter, melts. And that has a very specific characteristic in terms of the color and the texture. If they're primitive meteorites, they contain all the original amount of iron that there was in this rock to start with, so they'll be heavier than your normal rock, and they'll typically be magnetic. This is an iron meteorite, and an iron meteorite is actually... Kids. I'll put it on eBay. If you focus, it says property of NASA OSIRIS-REx mission. One of my favorite meteorites is actually extremely rare. It's a sea chondrite. The composition of these meteorites is very, very close to that of the sun. So that's the starting material from our solar system. So we have this specimen here. It doesn't have any evidence for terrestrial contamination from Earth's atmosphere. We decided that, okay, this meteorite can allow us to answer a question about the origin of water and how it potentially relates to the water on Earth. So now it is sitting in an argon atmosphere, so it is protected from any atmospheric water that could contaminate the meteorite. When you do research on meteorites, you actually have to extract the information from this object. You need to slice it in thin slices so you actually can look at the inside of the object. You might want to dissolve part of the rock, then you would separate the different elements and you analyze the isotopic composition, and that could tell you something about their age, where they come from in the solar system. One of my favorite types of meteorites are pallasites, and they represent the collision between two types of asteroid where the core of one asteroid mixes with the mantle of the other. So beautiful pattern and extremely rare. Why has a planet the potential to develop life? So I'm really interested in knowing whether there's a secret recipe that needs to be there for a planet to have the right conditions to develop life. So if having the key ingredients necessary for life is a sort of a predictable outcome of forming a planet like Earth, then I would say that, you know, life is probably widespread in the universe. I think that's really fascinating. It's also the unknown. So sometimes you don't know what the answer will be, but suddenly the answer comes from that meteorite, and it's not something that you expected. I think that's what makes my job interesting. A new discovery might actually prove one of your theory wrong that you had before. That's how science moves forward. There's nothing wrong in being wrong, because else you would never move forward, right? So you have to be humble in the sense that there can always be a new discovery that actually changes the way we think about how the Earth formed, which is very different from how people thought before. Nothing is set in stone, so to speak.